My name is Sepp Hochreiter. I'm the inventor of LSTM. This podcast is always very, very interesting, especially for guys who want to apply AI in industry.
I am listening to the AI podcast from the very beginning. Robert and Peter have the ability to cook down the very complex matter of AI in the industry in such a down-to-earth way that people that are no experts can understand where the technology is heading to in general and what fundamental changes we are about to experience in the near future. They do that by interviewing experts from the industry itself and always manage to make the transition from expert talk to easy, understandable content. AI Pod is definitely one of my favorite shows and the best AI podcast that I personally know of. Philipp Paschen, CDO, Witzemann Group, Germany.
Hi, this is Karina Mead from Women in AI and Robotics. Congratulations on the 200th episode, dear Robert and Peter. You always have the coolest guests from the industry, and I use your podcast to stay up to date with all the latest developments in the AI field. So looking forward to the next 200 ones.
Happy 200 episodes of the AI Pod. This is Michael speaking from Bosch Rexroth. Over the time, I have to say, honestly, that you became my go-to source when I want to inform myself about what's going on with AI, especially in our industry. I would like to thank you for that. Keep up the good work for the next 200 episodes. Thank you very much.
This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and it's a pleasure to talk to
Peter Seeberg. Hello Robert, how are you doing?
Yes, I'm fine, Peter. We started this anniversary episode with 4 listeners, representative of many others from the industrial sector. Thanks to Professor Dr. Sepp Hochreiter from JKU Linz, to Philipp Paschen, Witzemann, Karina Mead from Women in AI and Robotics, and of course Hans-Michael Krause from Bosch Rexroth. Thank you very much for your kind messages and your congrats to our anniversary episode. Thanks a lot. Peter, 200 episodes.
Wow.
Let's look back a bit.
Who would ever have thought that?
Oh.
When you... I'm not sure how it started. Where do we start? I mean,
we started in German. Yeah, that's the first in German.
That's one thing, yeah. But the place where we were, I mean, and maybe we did something before, but there was this conference,
yes,
VDMA, the German Association of Machine Builders, and I did a presentation there, and I think at the end of the presentation, you asked me for an interview.
Yes, exactly. For Hannover Messe. Yeah.
Was that the first time we met, actually? Or not?
Yeah.
Oh,
yeah.
And that must have been sometime fall of 2018, I believe.
Yeah.
It was very special. You recall you had a colleague with you. He was making a video, I believe. And as I'm a tall guy, a tall Dutch guy for those people who don't know, I think there was a person standing on a pile of books, just the camera, right?
Yeah.
But we did it the other way.
Yeah.
So I made my legs kind of on a 1 meter outside, and
like
I look like a giraffe.
Yes.
There is actually still a video somewhere. I think it's on YouTube. I think we can link to it or not.
Yeah, absolutely. Yeah, it was the first time because we did an interview for Hannover Messe about industrial AI, and then we had a little chat, and then we said, okay, let's try this podcast staff about with industrial AI.
Yeah, there was a second thing that was kind of funny as well, is that I recall that maybe I did the first kind of was it a keynote or it was at the beginning of the conference, I think. Huge, big new topic, artificial intelligence.
Absolutely, yeah.
And we were standing there, and towards or somewhere towards I believe the end of the interview, you see over my shoulders, you see these bodyguards come into the conference room, and then you think, oh, what's going on here? And it was at that time finance minister, today chancellor, who was doing a presentation after I had done my presentation. That was the.
I think it's very interesting. You talked about the CRISP DMM, right? I think so. It was CRISP.
I do as well. Yeah, okay.
Yeah, I think so. So it was really the beginning when the industrial sector woke up to think about industrial AI. It was 2018, and there was nothing about ChatGPT or generative AI or sharing models or something. Yeah.
No, I don't really recall how it was received. I mean, I'm sure there have been still a big share of the audience that was saying, okay, yeah, let him talk something.
Yeah.
This is not going to happen anyway. And here we are, 4 years later. And we can almost say it's only starting right now,
Yeah. For all our listeners, we also have a main part in this episode about a real topic and not about our 200 episodes. We will have a use case with CLAAS. It's very interesting. So you have to listen to our backflash about 200 episodes, and then we start in the main part with CLAAS. Yeah,
we don't make it longer than 5-10 minutes. You can always fast forward. But we will do it in such a way that maybe for those of you that have not been our listener for over 4 years, maybe you can at least know that what we have been doing. And, as it is about the long tail as well, you can always go back to some of these. So maybe, it was your idea. You suggested then later on, I believe, you suggested why not make a podcast out of this. And the first one we did, I look back, it was January 31, 2019. So it's over 4 years. It was one of the folks was Oliver Niggemann, a professor at that time. I don't know where at the moment he moves. He's in Hamburg. At the moment.
He was in Lemgo, I think.
I was at Lemgo, yeah, right.
Yeah.
Okay. Number two, we talked about use cases. Oh, and by the way, that's very interesting, right? So I think Oliver has been with us one more time, and he just produced a paper together with two students, Alexander Windmann and Henrik Steuder, I believe. If you hear this, I already proposed, because you have this paper with the wonderful name of Robustness and Generalization Performance of Deep Learning Models on Cyber-Physical Systems. And we would love to have you, Oliver, or, Alexander or Henrik. Please let us know. And we're looking forward to record with you. Yeah, that was the very first episode.
And we had an episode with Aschenbach-Buschhütten. You remember this guy? Aschenbach-Buschhütten, yeah. Very interesting.
Steel production? Or?
Yeah, steel. No, aluminium. Aluminium was it, I think.
Oh, okay.
Yeah.
Good. Yeah. So what
at
the
beginning, we had 48 downloads on this podcast.
Oh, was it?
Yeah, 48.
And we were probably very proud, I think.
Yeah, absolutely. But half of the downloads came from us, because we want to check everything is fine. So 48, yeah.
So what are your other episodes to remember? I mean, we have now 200, so we're going to be doing our 200s today. Which are the ones that you that comes back in your brain when thinking about what we did?
We had a very interesting episode. We talked with Marco Huber and Professor Sluzalek from DFKI about explainable AI and how to solve this problem from a black box to a gray box. That was very interesting.
And Marco Huber is going to be with us again in the conference. We'll talk about that later when we talk about maybe extensions of the podcast. Right. Okay. Yeah, I recall that one. Yeah. Mm-hmm.
Yeah. And another episode that comes in my mind is the episode with Festo, with Jan, with a vision of Festo and talking about can machine build machines. This is a very good headline for the podcast. Can machines build machines? Yeah.
Yeah, and I heard it back again only a couple of weeks ago, when we were at the, the internal Siemens conference.
Yeah, yeah.
Because when we visited Jan, when was that, a couple of months back, at Festo, for whatever reason, I couldn't listen. It was a very good presentation, yeah.
Yeah.
I recall, of course, Sepp Hochreiter, he's kind of our, what should I say, our mental supporter. We are, especially you, are very close. We talk a lot with Sepp, inventor, together with Jürgen Schmidt-Huber. We did one together with him, co-inventors of LSTM. We've been following from the very beginning. So has always been great to hear from him. What was his first famous quote that he did in the article that you wrote?
Vermasselt es nicht in German.
Yeah, right.
What is it in English?
Don't screw it up.
Don't screw it up. Yeah.
Maybe we should say, don't beep it up.
Yeah.
Don't screw it up. He said, what did he say? He said, like, don't look at what the others are doing. Just go for it yourself. And he also said, he gave the example of, using, voice control, right? Tell your machine what to do. That's going to be happening.
True.
And you as machine builders, as the example he gave, you need to take AI in your hands, embed it into your machines, and send it out into the world, right?
Absolutely. I want to recall, because now I thought about what episode I also recommend to our listeners. It's the 2 episodes. One with CLAAS. He's our guest at the conference. We will talk about that later, about the future of vision. That's very interesting, because computer vision, as Knud Lasse Lüth told us, is one of the main topics for the industrial sector. And of course, the episode with Frank Hutter about TAP PFM, because we have a lot of tabular data in the industry. And that's also very, very interesting episode, I think.
Okay, so when we talk about the conference already 3rd time. So
we should talk about the conference, yeah.
Yeah, we can do it now. And then we come back, because I'm not yet ready, but it's okay. So we can talk about extensions of our podcast. I think the first extension that we did, we were looking into a conference already in the first or the second year, maybe. I don't recall if we did it or not, but in the end, we did not. Okay, there you go. But in the end, we did have we called it what? KI im Kloster was in German, AI in the cloister, I guess, or?
No, it's not a cloister, it's a monarchy.
Monarchy.
Monarchy, yeah.
What is a cloister then? Okay, what are you doing?
This is the Netherlands, cloister. What is that?
Maybe. In a monarchy.
AI in the monarchy.
Hey, stop. Here's Barbara. I edited the episode, and I was also at the event in Würzburg, but I was not in a monarchy. I was in a monastery. We don't have a king or a queen in Germany.
It was called like that because it was in Würzburg, right?
Yeah.
And it was a former monarchy, actually. So that was the first time we had a group of what, 15,
20, yeah.
15, 20 AI CTO level decision makers around artificial intelligence in industrial. And that was so successful that we decided to continue doing that. And for that reason, you have been working very hard, and maybe you want to say 2 words on it.
Yeah.
Next conference.
That makes us very proud, because we have managed to get to know the audience at our events. And in July, we will have the meeting in the Alps in Austria, in Zug. There we have men and women from Trumpf, from Dürr, Phoenix Contact, Lenze, Festo, Keber, and many others in the mountains. And I think the special thing about our conferences is we have no PowerPoint presentations there.
Right.
We have 3 experts. We have CLAAS from Qualcomm Lab, Marco Huber, Fraunhofer IPA, and Sepp Hochreiter. And these 30 men and women from the industrial sector can discuss their use cases, their problems, their ideas with 3 experts, and that makes us very proud. I think that's a special one for our event or our conference.
Yeah, actually, we don't need to kind of sell it or market it. We're completely full, but who knows? Maybe for the next one.
Absolutely.
This time we have 3 separate sessions, right? So the first time we had 2, right?
Yeah, we had Marco and Sepp, and today we're very happy to have CLAAS also on board.
Yeah, right. And that's why we said, and then we're already thinking about the next one is going to be also with Frank Hutter. It's going to be AI in the
forest.
In the forest, in the Black Forest, right?
In the Black Forest, and we talk about TAP PFN and AutoML. Yeah, very interesting.
So that's one extension, and the other one we did before that one actually was AI in the canteen, right? KI in der Kantine in German it's called.
Yeah.
So we've been out for a couple of times, and that was about. I think it was an idea, probably yours, because you always come out with these creative ideas. But what I thought when you suggested was what I did at Intel. It was like working lunch. You would come, you would bring your sandwich, salad, and sit there. And that's what we do. So we haven't been doing it for a couple of months, but there's 1 or 2 that we're doing in the autumn.
Yeah, with Philipp Paschen. Greetings to Philipp from Witzenmann.
Right.
We will meet each other in September at the AI in the canteen. Yeah.
And the idea was all about, maybe we talk about our listeners, who are our listeners later on. It's not only the, CTO level decision makers. There are students, there's people in any kind way related to artificial intelligence in an industrial environment. But we've always said like that we believe that everybody, so let's say, the 500 million Europeans, the whatever 1.x Chinese, so whatever, are 6 plus 8, 9, 10 billion people around the world. And actually that's interesting now, because yesterday I saw Andrew Wang, who's we haven't had Andrew yet. Andrew, if you're listening, you're very welcome as well, especially because you're so strongly developing your activities in the industrial environment as well. And he was suggesting, everybody's, I think he was saying students need to learn AI and also coding AI, to which I said, AI principles, yes, very good. I do strongly agree. I've always agreed, but I've never agreed on the coding, especially now as AI is taking over coding. It doesn't matter. So that's what we do with the AI in the canteen. Do we have any other things that we do? We do follow or support conferences like we did with Festo, Siemens. Those are the kind of things, right?
Yeah, absolutely. That's our thing. And maybe I brought a few facts to the podcast, and I have some challenges for us where we have to catching up some listeners, because in Sierra Leone, Zimbabwe, and the Faroe Islands, we have only one listener. So we have to keep up a little bit in this in these countries. And in Papua New Guinea, Turkmenistan, and Madagascar, we have no listener. So zero. So that's very
change that.
Yeah, we should change that. But the main listeners are the German, Switzerland, Austrian connection, because we started in German, and then it's Italy. Very interesting. Italy is very strong. US, and then we have Netherlands, Denmark, Norway, Sweden. South Korea is very strong there. UK, but I'm very surprised that, for example, France or Spain, Portugal, there are only a few listeners in these countries.
Well, I would suggest there's a strong correlation between the countries you just mentioned and industrial production.
Yeah.
When you say, for example, Italy, the north of Italy, is
sure.
In packaging industry, for example.
Yeah, absolutely.
I mean, and that's, of course, what we are. When I look at my LinkedIn and I see that I have contacts in banking or in retail, or sorry, if for those, because I need to delete them, because I need more. I do want to be available for people in the industrial environments. And that's what we do, right? We have been looking once into agriculture. We have been looking into autonomous driving. So let me recall one of my favorites has, of course, been the interview with Ansita Dickman, which finally resulted into him receiving the highest -1, let's put it that way, kind of award from the Federal Republic of Germany. So we're very proud of that. Yeah. That's what we're doing as well. But normally, we concentrate on whatever is industrial. So production is the core, machine building, and all kind of many different topics around that, which maybe we shouldn't necessarily go into with. Well, there's actually so many, and I think all the topics that are really important for you listeners, who are already inside or not yet. I mean, in the course of the 4 years, and since a couple of weeks, months with ChatGPT, everybody's waking up. But we started it 4 years ago.
Yep.
We said there's something big coming. Prepare yourself, and and all the topics that are important for considering, introducing artificial intelligence, machine learning, language models now. That's what we've been talking about, processors, algorithms, a little bit of base understanding of what is supervised, what is unsupervised. And, and some of them we repeat all the time, like edge, like data, small data. We've been looking at trustworthy AI from the very beginning.
Yep.
We've been following what the European Union, but also other parts of the world have been doing until now. They've decided that they're going to go for it, right? So,
and you recorded one episode, I remember, about the first episode we talked about reinforcement learning. It was AXO or something, it was a packaging company or something. Very, very interesting. It was in the...
I recall. Yeah. They had he had actually been doing that also for VDMA, I believe.
Yeah, exactly.
He was saying you need little data, and it was amazing how he had improved the throughput of his machines, which was about I'm not sure how
it's
how
packaging or something, or process industry or something.
Yes, process industry, and not with fluid, but with other kind of
ASO, I think.
I think it's ASO, and that was very, very interesting, very high level. And we've always said, like, reinforcement learning is one of the most creative. Now, I'm still sure that's still the case, but then, suddenly, almost from the side, we see transformers, we see diffusion models coming, and the world is suddenly upside down with creativity. It's almost like nobody had really expected it the way it's now turning out to be.
Absolutely.
So, what is more? We're not going to go through the topics.
No.
Maybe you want to mention the partners that we've had so far.
Yeah, because without you, the format would be unthinkable. And the first thanks goes to our listeners, sure.
Yeah.
But we also have our podcast partner. When I recall, it was Hannover Messe, it was Adesso, Time Echo, Pragmatic Industries, Zülke, Cthulhu, Nime, and Siemens. Thank you very much. It was a pleasure to work together with you.
Yes.
Without you, the format would be unthinkable. Yeah.
Very good. Final comment from my side. And then maybe you want to talk about what you listeners are going to be hearing today. We discussed, I believe, last time, 2 weeks ago, that we have now this partnership with the Women in AI. So I look back again, and I think we discussed it 2 weeks ago. So after 200, we only had, I think it's eight women, and that's going to change. That's going to change because of the partnership. You already did the first recording, I believe, last week.
Last week it was very interesting. I think we will publish this in July, so it's very interesting. Yeah. But before we start in the main part, we need to thank to our team, Peter, because most people out there think that we are the podcast, Peter and Robert, but we have a team in the background. Without this team, we would be unable to do that. And we will thank to Barbara, Anne, and Simon. They take care of editing, uploading, social media, and the whole event organization. So thank you very much. It is a pleasure to work with you together. Yeah.
Thank you from my side also, Barbara, Anna, and Simon. You make these wonderful waffles, what they call.
Audio images,
Those listeners that do see us maybe on LinkedIn, elsewhere, these wonderful, audio
images,
images, visuals, and also do those, and all the recordings. So sometimes we're lucky, we record and they can take it just one-in-one. There's not a lot of work. Sometimes people are a little bit, it takes a little bit more cutting out things. And actually, when we look back, there was only, of the 200, they have all went fine. There was only one that we had to delete because as soon as we put it live, the person we did the interview with, or their manager, I believe, wasn't happy with what was up there. So we didn't have another way of just taking it down. But except for that, everything has been fine. Looking forward to
the next 200.
200, Robert.
Yeah, absolutely.
That's another 4 years, I guess.
That's another 4 years. And we have to catch up a little bit in Sierra Leone, Papua New Guinea, and Turkmenistan. Yeah.
We'll do our best. Thank you very much, listeners.
Thank you, Peter. It's a pleasure to talk to you every week. Yeah.
Thank you, Robert, for the great initiative. It's been a pleasure.
And we switch now to the main part and have a very interesting project with Fraunhofer and CLAAS. And CLAAS is a machine building company in the north of Germany, and it's focused on agriculture. Right. And we talk a little bit about the engineering process and some topic where they have a project on AI. So enjoy listening, and we will hear each other after our event in the Alps.
Very good. Looking forward to it. It's like for little old boys when you have these the big tractors, right? When you see it come by, I always think, I want to jump on one of these and ride them too. As long as you can still ride them, and maybe you're talking about that.
Yeah, Robert, the future in agriculture business is AI. So there's a lot of AI on the field and in the trucks and on the tractors. So it's very interesting. Yeah,
I can imagine. Thanks. Bye bye.
Thank you. Bye bye. My guests today are Roger Tiaco Ponguet from agriculture machinery manufacturer CLAAS and Fabian Hanke from Fraunhofer IEM. Hello, Roger.
Yeah, hello.
And hello, Fabian.
Hello.
I'm delighted to have you with us. Please introduce yourself briefly to the listeners, and later we will talk about your AI project. Roger, would you please start?
Okay. Good morning also from my side, and also thanks for having me today. My name is Roger Tiako Punge. I'm working for CLAAS as a domain lead for computer-aided design mechanical.
Okay.
And I'm responsible for the domain CAD mesh. I'm responsible for tool, method, and process.
Mm-hmm.
And I'm also the CLAAS project manager for the research project integration of AI, artificial intelligence in the computer-aided design, where we are here today and where we have to talk about our results.
It's a very interesting topic, computer-aided design and AI. I think a lot is happening in this field, right?
Yes. There are currently a lot of things are going on, and that's also why we wanted to be part of it and participate on the project.
Yeah. Fabian, please introduce yourself briefly.
Yeah. Also, thank you for having me. I'm Fabian Hanke. I'm a research associate at the Fraunhofer IEM, which is located in Paderborn. And I'm working in the Department of Systems Engineering, and to be more precise, in the group of the digital engineering. And actually, I have a background in mechanical engineering, but during my studies, I focused on AI, and now I'm conducting research in the field of AI applied in product development.
Yeah, let's start with your AI project. Roger, what was your pain point and why?
Our main pain was, let's say, the searching time that we have from the designer or from the manufacturing guy, and also the fact that we wanted to be, let's say, more involved about the topic artificial intelligence on computer-aided design.
Can you explain a little bit your process, your computer-aided design process?
Our computer-aided design process, you mean how we are currently working?
Okay. Yeah.
So basically, the designer, let's start with the use case for the designer. So the designer always work on the live structure, and they are looking for a specific part that they used to work with or they used to design in the past. So they have to search for it. As I said, difficult to find the part that they used to create in the past.
Mm-hmm.
And with that, they have to create a new one. And at the end, that means we create a lot of doublet in the system.
Mm-hmm.
Once we create a lot of doublet, that means we spend a lot of money. And with the project, we wanted to, on the engineering side, we wanted to reuse pre-developed part to avoid that the designer create part that are already existing. And we also wanted to reduce the part variance on the engineering side.
Mm-hmm.
On the manufacturing side, we have a lot of machine setup, just to the fact that the designer always create parts that are already existing, and they just make a small modification on this part.
Mm-hmm.
And with that, we think we will be able to reduce this manufacturing setup on the manufacturing side.
Did you ever? Please go on.
For the processing, it's also difficult to, let's say, to challenge the parts, to challenge the price of the doublet on the market, since they don't know approximately how much the parts cost, since the parts are already existing. And so with that, we think it would be easier for the manufacturing guy to say, okay, the part that we are currently building is already existing, and this part costs in the past about, let's say, 20 euros. And once, if you want to do a similar part, then we will have approximately the same price.
Mm-hmm. Yeah. Have you ever tried to solve your problem without a machine learning or AI tool, or what was your approach before the project?
So before the project, we tried to make a kind of classification to help the designer to see approximately which part he can use and which part he want to use.
Mm-hmm.
The thing with the classification is you first have to define all your classes alone.
Mm-hmm.
From time to time, it's not so easy because you have several parts, with several attributes, with several classification. So at the end, you first have to know exactly what you want to have. And it was also easier. So that's also why we wanted to be part of it.
And one more question concerning the starting phase. How did the idea to solve this problem with AI come about? Was it an idea by Fraunhofer, or was it your idea and your team think about AI and machine learning?
It was one of our ideas. Let's see, before we start with the project, we wanted to have a tool who are able to, let's say, to find similar parts just with help for the geometry. We make a lot of some workbench to see what is going on the market, what is currently, let's say, available on the market. And it was difficult for the company who present the tool on our side to give us, let's say, the info that we wanted to have. How is it working in the background? How are we able to classify the part? How are we able to find the part? So it was always a kind of we don't know exactly how it's working, but it's working, and you will be able to find your part. So at the end, to be let's say, to be prepared for the future, you always have to know exactly how the thing is working in the background, and this is the info that we didn't have doing all this workbench with a lot of supplier. So most of them were just saying it is working. We are able to find similar part. But if you work with us, you have first to classify your part. You have to give us the classification so that you are able to put, let's say, the part on the classification. But how to create this classification, you have to do it by yourself. So I think this is the most important point there.
Fabian, can you describe us what was your approach to solve the pain of Roger and his team? Sorry.
Yeah, of course. Usually we start with the problem analysis, doing the concept creation. After that, we will start with the implementation process, the verification and validation, and finally we will conduct the deployment and the operation. During our problem analysis phase, we will look into the problem and get a better understanding what really is the challenge behind the task. And we will identify use cases, analyze the stakeholders, and after that, we will define the current state of the process and how they are actually working. And on this base, we will start to create concept. We will conduct data engineering. We will look into the data, what data is available, in which quality and what amount. And we will start to pre-process the data accordingly to multiple possible AI solutions. We will try to benchmark after that. We will create each of these AI solutions, conduct different verification processes, and figure out which one performs the best. Obviously, we will select the best performing one and start the actual implementation process, which is usually not only the AI model, but more the whole software solution around the model.
I think that's very important.
Yeah, really it is. Including
a lot of people are missing this part in their project.
Yes, it's a really crucial task to integrate it in the overarching IT ecosystem, which is, for example, here in the use case with CLAAS, the CAD environment, and to integrate the solution into this so that the user can really access our solution through the CAD tool and use it to identify possible similar parts. After we implemented this, obviously we start the verification and validation. We conducted unit tests, integration tests, as well as validating the human-machine interface by providing the solution to key users, which got the possibility to use it and figure out if it suits their requirements. And after that, we gathered all the feedback and tried to integrate it and improve our solution. And we are planning to deploy and operate this system in the future.
Okay, let's look under the hood, Fabian. Let's talk a little bit about your AI solution for this specific use case. What kind of data set, what training, what learning algorithm are you using, and why?
Yeah, so we are conducting a geometry comparison, which is kind of special for our solution, because usually what I found is a lot of other part comparers use computer vision to compare the different models by using a snapshot of the part and comparing these pictures.
Yep.
And what we are doing is we are actually comparing the model geometry. And how we are doing this is we start with step model, which is usually created by the CAD modeler or engineer automatically. We are deriving 2D representations of these model. So what is this 2D representation? So it's basically a histogram which represents the distribution of distances on the model surface. So you can imagine we have this CAD model, which is basically a representation by a lot of connected triangles, and we can select randomly points on the surface. So we're usually selecting 2 points or a pair of points, measuring the distance. And now we're doing this process for 1024 by the power of 2 points. So really a lot of points on the surface. And the result will be a length distribution over the whole part. And we are collecting this in form of an histogram. And this is our representation of the model. And our solution will compare the 2D representation of the models. And if the histograms are similar, we can say, obviously, the 3D geometry is also similar.
Okay. And can you please, once again, explain in a few sentences why you did not choose a computer vision approach?
I would say the huge advantage is that the computer vision approach will usually have just one angle of view on the part.
Yeah.
And we have like multiple or infinite views on our part because we use the really 3D representation. Because usually if you just take a picture, you will lose information about your product and the geometry.
And how big is this data set you are using?
Multi-million files.
Okay.
So it's a pretty huge data set. And this was quite a challenge for us. So we also created a pre-filtering process to reduce our computing time, because this histogram comparison is quite good and results in high quality for our prediction, but it's also kind of computing expensive. So our goal was to reduce the computing time to lower than 30 seconds. What we have done is we created multiple pre-filtering solutions based on different attributes. One approach was to conduct k-nearest neighbors and identify neighbors in the nearest space. Also, we developed a clustering solution, and our last solution was based on the bounding box ratio. So you can imagine you can create a bounding box around your model, and there are basically 3 dimensions. And we can create the ratios between every dimension, like x to y, y to z, z to x. And these relations will give us the possibility to just filter all the models, and we are just looking at possible matches which are under a threshold from like 1% difference in regards to the bounding box. And after that, we will conduct the actual histogram comparison. And the result was we have been able to search the whole multi-million model data set within a few seconds.
Wow. Roger, let's talk a little bit about this deployment of the model. How difficult was it now to deploy this model on your software and on your daily work base?
Let's say the model is currently not yet, deployed for all designer, let's say like that. So the model are not used internally by some designer, by some key user, by some key aspect user who is now, testing the tool, working with the tool, and seeing if they are, comfortable with the UI or the UX. And so we still have, 1 month left to work on the project and to refine the project, to refine the, the requirement of the designer. And at the end, we have to decide how we want to go forward with the tool. And also take into consideration that there are also tools on the market who have other UI and UX. So we also have to take this into consideration. But currently, the tool is used for, let's say, for some department who already see the benefit of using that, and already wanted to make some try and see exactly how they can use our tool live on production.
Can you measure what improvements have been made with this tool, with this key users?
Also for the user who are using the tool currently, they are much faster by finding similar parts.
What does it mean? 50% or 10% faster?
I will say more than 50% faster. Since, as I say, if you have a model visible, you just have to click on the tool, and less than 30 seconds. So the last test that we made, we were about 17 seconds. So we were able to find similar parts. And we are also looking for, let's say, searching from 1 to, 3 million parts that are available on the data on the system. So less than 17 seconds, you are able to find a large of similar part that you want to use. There are also several, let's say, filtering possibility that we implemented on the tool. And with that, the user is able to, let's say, compare the part that he have, the reference part, and with the part that he find out, and he can make a kind of visual comparison, and at the end decide if he want to use the part he found out or if he want to continue with this part.
Okay. Fabian, you want to add something?
Yeah, in the first place, the engineers haven't even been able to search through the whole database. So our improvement was really quite a lot. So because no human would even be possible to look through 3 million CAD models.
Yeah. Can you describe a little bit this deployment strategy or this deployment process to the key users?
We will try to deploy it in the AI Marketplace, or we have actually deployed like a demo version of the solution in the AI Marketplace, and we usually use like Kubernetes clusters to do that. So in the first place, we will create a Docker container, and we will use AWS to set up a Kubernetes cluster and deploy our solution there. And after that, one user or multiple users could access our demo simultaneously and test out whether the functionality would suit them, and maybe if they're interested in some kind of a similar solution. And after that, they're able to make a request, maybe even to buy the application.
Roger, you want to add something?
Basically, no. I think Fabian already gave a good hint about the AI marketplace on CLAAS side. So currently the tool, we have an internal application where we are able to put all the, let's say, the relevant application we develop. And once it is there, it is already available for all designers, and they are also able to use it. So for that, there is no specific deployment process on CLAAS side.
Okay. Fabian, I have one more question to you. How does the model need further training, and what are the ML ops strategy on this topic, or the ML ops pipeline?
For now, we don't have actual ML ops pipeline. The further training is not that crucial because it's just possible to add new parts to the system, and automatically the system will derive the individual histogram for this new part, and also key features like mass, surface area, and so on, and save it to the class SQL. And our system just search through the whole SQL, including obviously the histogram, and so it will find also the new part. So what we need is this process of integrating new parts, but it's automated.
Okay. Our last question in our podcast is, since December last year, is to talk a little bit about the elephant in the room, how generative AI will change your idea or your process. What is your opinion on that, Fabian? Does it impact your model or your idea?
I wouldn't say so.
Okay.
So it's pretty interesting, and the possibilities how to use it. I think our solution can be integrated and merged with possible features like for a few days ago, on the System Mobility conference, I met a colleague of mine, Bastian from Research, and they are providing an enterprise search application. And for example, they have these like Google for your company, and they're using similar to Google. They will find your documents, Word documents, etc. And they also integrated a Copilot, which is based on ChatGPT. And I could imagine something similar. So to create a software solution, which on the one hand side will identify possible similar parts in your data set, but also maybe a Copilot which helps you to communicate with the system. So natural language is obviously a better process to interact with the system, and maybe it will be helpful in the future to be more natural for the users to work with the system. So I see it more like an enhancement for the interaction rather than a really solution to, in this case, find similar parts in the data set.
Roger, what about generative AI and design processes at CLAAS?
Let's say all the several approach that we have. For me, it's let's say it's not no. I will just talk about this the part CAD. We see a lot of potential of let's say of AI and computer-aided design. So as I already said, this is also why we wanted to be part of the project. Most important thing or most difficult thing for us at the beginning was let's say to find out which relevant information, which CAD relevant information are needed for artificial intelligence. It was, let's say, at the beginning not so clear, but since we work on the project, so we have, let's say, more and more clarity about AI and on computer-aided design. Want also to further improve the topic and go a little more deeper on the topic also with finite element analysis. So how can we, let's say, combine both together to have a, let's say, suitable model? So I will say this is more or less a thing that we learn also on the project, and we want to go forward on the direction to also include it and finite element analysis on with computer-aided design.
Perfect. It was a very interesting project. Thanks a lot for sharing this project with us. Thank you very much, Roger.
Thank you also for myself.
And thank you very much, Fabian.
Thank you too.
Bye-bye.